Hello guys, and welcome back to our YouTube channel. In the last video we were talking about periodic functions. So in this video we are going to continue with compound periodic functions. Okay, so this is what we are going to be doing in this video. Okay, so a compound periodic function is defined over a base interval and extended across the real line by repeating with a given period. Okay, so a compound function has more than one definition and intervals, but a periodic function, it had only one definition and an interval, but this is more, it is further, it has more than one definition and an interval. So we are going to go straight to an example. Let's have an example. So let's say let me just take f of x. There's no difference though. F of x equal to, so this is our first case, and our second case is this. And we have a period of 4, and we are to find g of -6. Okay, so this is what I was talking about. Here it has more than one definition and interval, and here we have been given a period. So remember I told you that in other cases, in some cases, a period would not be given. In some cases we will not have a period, but in this case we have been given a period. If we were not given this period, they would have given us the period in a different form. So if they did not give us like this, they would have given us like this. So, and from here we can know that our period is 4. But here they just told us directly. Here we're told directly that we have a period of 4. So let's start. Step 1, we have to sketch the base interval. So let me just put sketch the graph. So we cannot just start sketching the graph without its coordinates, so we need to derive its coordinates, and here we have been given 2 intervals and 2 definitions, so we are going to have the coordinates in these 2 different cases. So let me draw my table again. This is x, this is y. So the values of x have been given. We have been given our intervals of x, that is the values in which our x ranges from, and we are to find the values of y. So in this first case, x, we are going to have 0, 2. In this second case, we are going to have 2 and 4. Okay, so remember I told you guys that in this range there are many values of x, but we are just going to take only these 2 in which we can see there. Okay, so let's take the first case for x equal to 0. For x equal to 0, we are going to use this function because 0 is in this interval, so we are going to substitute in this function to get the value of y. Remember, y is equal to f of x, so we are going to substitute 0 into the first one, so we are going to have 0 plus 2, which is equal to 2. So when x is 0, y is 2. So let's take 2. We take 2 when x is equal to 2. So we are going to have 2 plus 2, which is 4. Let's take the second case. When x is equal to 2 in this second range, we are going to have 2 squared, which is equal to 4. So it's the same thing. And let's take the second one, 4. When x is 4, we have 4 squared, which is 16. So we have 16. So these are our coordinates: 0, 2, 2, 4, 2, 4, 4, 16. So this is x, y, x, y, x, y, and x, y. Okay, remember we need to know whether it is closed or open. So we have the first case, 0, 2. 0, 2 was from this first case, and 0, 2, the two of them are in the interval. So 0 is in the interval, 2 is in the interval. So it is closed. Let's take the second case, 2 and 4. In this range, 4 is not in our interval. 4 is not in this interval. So let me just wipe all this. Let me just write it back. Sorry. Let me just write it back. X plus 2 by 0 and x squared for this range. Okay, so as I was saying, 2 and 4, we derived it from this first interval, and as you can see, 4 is not in this first range. So from there we can conclude that it is open. Let's take the second one, the next one, 2 and 4. 2 and 4, we derived it from this interval, from this range. 2 is in the interval, 4 is in the interval, so this coordinate is closed. And 4, 16, 16 is not in this interval, obviously, so it is open. Okay, that is what we have. Okay, so this is our table, x and y. Okay, here we have not been given a range in which we are to, we are to put our x-axis. So we are just going to draw our x-axis depending on the values of our x, depending on our coordinates, on our x coordinates. That is how we are going to know the range, the intervals of x, like how we are going to position our graph, how we are going to position the value. Okay, so let us draw the graph. Let's draw the graph. Okay, so our x here, this is obviously 0. So our x ranges from 0 to 2 to 4. So we are just going to have 1, 2, 3, 4. Here we are going to have -1, -2, -3, and -4. That is our x-axis. So our y-axis, we can see that the highest value of y we have there is 16. So we are going to put this one up to 16. So let's just take from 2, 4, 6, 8, 10, 12, 14. Let me extend this. 14 and 16. Don't mind the graph, it's just a rough sketch. Okay, so this is what we have. For the negative values, we don't have any negative values of x nor y, so we can just put this, we can leave it at that. Okay, so let's draw the graph with respect to our coordinates. So let's take the first coordinate. We have x is 0 and y is 2. Let's go to our graph. X is our x-axis. X is 0, y is 2. So this is where we are going to put it here. But remember that coordinate is closed. And remember in our last video, I told you guys that a closed coordinate, we draw it as a dot. Okay. So that is our first coordinate. Let's go to our second coordinate, 2 and 4. So here is 2 in the x-axis and 4 in the y-axis. So this is where we are going to draw that one. And remember, they told us that, sorry, from our observation, that particular coordinate is open. So remember, an open coordinate is just a circle. Let's go to the next coordinate. The next coordinate, we have 2 and 4 again, but this time around it is closed. So here is what we are going to do. Since one is open and one is closed, we are just going to put a dot inside, because closed represents a dot, open represents a circle. So we are going to put the two together as that. And our next coordinate, 4 and 16, it is open. So 4 and 16 up here, it is open. So that is what we have for that one. Okay, we are going to link our different points. We are going to link them. So let me draw. Okay, so that is that. Okay, so here our period was 4. Our period is 4. So remember in our last video, let me extend this. Okay, our period is 4. Since our period is 4, that means this shape that we have is going to repeat every after 4 units. So we are going to have the same shape on the graph every after 4 units. So this takes us to our step 3. Sorry, step 2. Step 2. Our step 2, which is to extend periodically. So let's extend this graph. If we are to extend this graph, then I should add. So we have 5, 6, 7, 8. Here we add it. Minus 5, minus 6, minus 7, and minus 8. Okay, that is what we have. So we are going to extend it both in the positive direction and the negative direction, because it repeats. Before we had this one, it already repeated in the negative direction. So we are just going to extend periodically. Okay, so let's count this. Let's start at this point. Let's count 1, 1, 2, 3. Put our dots. Let's go to this next one. Let's count 1, 2. Sorry, our period is 4, not 3. That I forgot. Our period is 4, so let's count 1, 2, 3, 4. Here, let's count 1, 2, 3, 4. And here, let's count. It's 5, 6, 1, 2, 3, and 4. So here it's an open circle. So let's link it. Sorry. So that is what we have. So I've extended it periodically. Periodically meaning extending because our period is 4, so we are shifting it every 4 minutes. So if we shift it in this direction, it's going to give us the same thing. So that is what we have. So let's go to the next case. The next case, we were told to find, here is supposed to be f because we are dealing with f of x. So we're told to find f of minus 6. So we have to find f of minus 6. Okay. So our f of x, in general, our f of x ranges from 0 to 4. Why does it range from 0 to 4? Here x ranges from 0 to 2, and in this second interval it ranges from 2 to 4. So in general it ranges from 0 to 4. So our interval is from 0 to 4. But minus 6 is below 0. Minus 6 is not in that interval. So we cannot just go ahead and substitute minus 6. So we have to find a value which is in the range. So we have to add 4 to minus 6 until it gives us a value which is in the range. Okay, let's go. Let's say, so we have minus 6 plus 4. What's minus 6 plus 4? Minus 6 plus 4 is minus 2. Okay, we have minus 2. Is minus 2 in the range? Let's check. Minus 2 is not in the range. Remember, it ranges from 0 to 4. So minus 2 is not in the range. So we add again. Minus 2 plus 4. This gives us 2. 2 is in our range. So we can say f of minus 6 is equal to f of 2. And since we have that, let's come here. We have our f of 2, but we have 2 ranges. So we have to figure out in which function we are supposed to substitute 2. So let's take this first function. We have x greater than or equal to 0 and x less than 2. X is less than 2, so we cannot take this one because there we have x is equal to 2, but here we are having x less than 2. So this, we cannot use that one. Let's go to the second case. We have x less than 4 and x greater than or equal to 2. So we can use this case. So we can use f of x equal to x squared. So we are going to substitute 2 squared, which is equal to 4. So we can conclude that f of minus 6 is equal to 4. Okay, that is what we have there. Okay, so let me just solve another. So let's just say find f of 13. You know, I've always been having find f of a negative number. So let's say we have a positive number now. 13, remember, in general, our range is from 0 to 4. 13 is not in that range. So we have to do something. Our period is 4, but here we cannot add 4 like we did in this first one. We will never arrive at our range. So in this case, we are going to subtract 4. Remember, the period repeats. So this function is repeating after 4 units. It repeats. So it repeats both in the positive and the negative direction. So here we were adding 4 because we had a negative number. So here we have a positive number. So we are going to subtract 4 from 13 instead in this case. So we are going to have 13 minus 4, which is 9. 9 is not in the range. 9 minus 4, 5. 5 is still not in this range. Remember, it ranges from 0 to 4. 5 is above the range. We will subtract again. 5 minus 4. 5 minus 4 gives us 1. 1 is in this range, so 1 is our value. 1 is our value of x. So since we had 0 to 4, 1 is in the range from 0 to 4. But now we have to know which function we have to substitute our 1. So let's take the first function. In this function, we have x greater than or equal to 0 and x less than 2. 1 is in this function because 1 is less than 2 and 1 is greater than 0. So 1 is in this function. So we are going to substitute our 1 in this function. But let me just tell you why 1 is not here. Here we have x less than 4. Yes, 1 is less than 4, but 1 is not greater than 2. So we cannot use this case. So we are going to use this first case. So we are going to use the function f of x equal to x plus 1. And since our value of x is 1, so we are going to say f of 13 is the same as f of 1. So we are just going to substitute 1. We are going to have 1 plus 1, which is equal to 2. So f of 13 is equal to 2. So this is very simple, very easy, and very straightforward, guys. So remember, we follow our steps. Remember the open and close coordinates. Remember how to plot the coordinates. When it is open, it is an open circle. When it is closed, it is a simple dot. And remember that a function repeats every after its period. So if the period is 4, then it will repeat every after 4 units. So that is why we need to extend our graph. And then remember to find all of these. They are not in our range, so we have to solve it and make sure that we end up with a value which is in our range. We have to solve it using its period which has been given. And that is all, guys. Thanks for watching this video, and I'll see you guys in our next video.